show what we talked about. So this session is recorded late. We're only 50 minutes into class. Oh my goodness. I feel terrible.
Ventilation.
Maybe. It's warm in this room too.
Yeah,
Maybe that's part of my problem.
bothering everybody.
Okay, so I am going to talk through these steps. If you don't want to stick around and hear it again, you don't have to. But I am going to talk through them for those who want to review the recording later. I'm not going to everything. Have a good weekend, Shelley.
Hi.
All right.
But I am going to talk through it. Okay. So this was where we calculated standard deviation. We had two data sets, data set A and data set B. And the first thing we did was calculate the mean. Now, notice I have blue circles with numbers in them, and those correspond to the steps in the formula sheet for calculating standard deviation. So the first step is to calculate the mean. Now, early on, we talked about what mean was. When I say early on, I mean early on today. And to calculate the mean, whose symbol is denoted X with a bar over it, I'm going to change color so I can highlight this as I go. So this X with a bar over it, that's the mean. So when anybody is talking about mean, this is what the symbol that represents. And the mean is calculated by summing all of the data items and then dividing by the number of data items. So we summed all of the data items in data set A and divided by 7 because there are 7 data items. And that gave us a value of 20. And then we did the same thing with data set B. We calculated its mean, and I didn't write mean separately, but the mean is the sum of all the data items divided by the number of data items, and we got the exact same mean. But they're clearly different data sets. And so a way to talk about the data set is to calculate the standard deviation. And like I said, that's what we're doing here. So step 1 was to calculate the mean. Step 2 is to find the deviations themselves. So we subtracted the mean, which was 20 in both cases, from each individual data item. As we worked our way down, we came up with the deviations. If you sum the deviations, you will get 0. And so that's not enough to help us out. So we have to do step 3 where we square every data item. Make sure that when you're squaring a negative, you put the negative in parentheses or even drop it altogether because a negative times a negative is a positive. But if you square a negative, make sure that you end up with a positive. That was step 3. Step 4 is to add together all of these squared deviations. That's step 4. And we did that with both data sets. Step 5 is to take that sum and divide by the number of numbers, this is the n, minus 1. So we took 28 and divided by 6, and it gave us 4.67. The standard deviation, denoted by an S, if you're looking at just a sample size, is the square root of that quotient. So the standard deviation of this data set is 2.16. We did the same thing for data set B and came up with a standard deviation of 10.8. So what that means is that the data set in B is spread out such that you have to go about 10 to 11 points from the mean before you get into the middle of the data on either side. Whereas data set A, you only have to go about 2 points before you get into the middle of the data on either side of the mean. So those are much closer together. A small standard deviation like with data set A, means the data are clustered pretty closely together. A standard deviation of 10 means the data are spread out much more so. So the larger the standard deviation, the more spread out your data are. That was how we calculated standard deviation. And those 6 steps are highlighted on your formula sheet, I believe on the 3rd page. They are also located in the book on page 802. Page 802 will give you the steps to calculate standard deviation. Okay, another thing we talked about was calculating the range. That is also a way to calculate the dispersion of the data, how spread out they are. So you take the largest value minus the smallest value, and that gives you the range. In this data set, which is a grouped frequency curve, we see that the range is 10. And we also calculated mean, median, mode, and mid-range. Those are measures of central tendency, how close the data are, or the central numbers to the data set. Mean, we just talked about on the previous window. That's here, where we added up all of the data, individual data items, and divided it by the sum, or by the number of data items. Now, we had 151 data items, but remember, this is a grouped frequency curve like we talked about on Monday. So what this means is we had 2 zeros, we had 1 1, we had 3 2s, we had 12 3s, we had 16 4s, and so on. And so we added up the frequency numbers to get the total number of numbers. Think about how we made a grouped frequency. We did tally marks. Every time we saw a 0, we did a tally mark. Every time we saw a 1, we did one. And then those values recommend or told us how many of those individual data items existed. So it's really the frequency numbers you add up to get the total number of numbers. And to get the mean, what we did was we multiplied the score frequency. And so we have those all listed down here. And these are those products. Once you have those, we just added those together, and that is the sum of all of the data items. So 2 3s, or yeah, no, I'm sorry, 3 2s. If we added those 3 2s together, we would get 6. If we added all 12 of the 3s together, we would get 36, and so on. So adding all of those would give us 975, and we use those to calculate the mean. The median is the middle number, and I think I defined that on another page. Let me show you that. The mean is the sum of the items divided by the number of items. The median is the middle number, but you have to arrange it smallest to largest. That is key to calculating the median. And it's not so much a calculation as just adding over until you're halfway through. The mode is the value that occurs most often. Mid-range is the largest value plus the smallest value divided by 2. So we're really taking the mean of the smallest value and the largest value. That's what we're doing to get mid-range. So let me go back to that group frequency curve. The median, when you have a large data set, is easiest found by taking the number of data items, adding 1 and dividing by 2. We had 151 data items. I added 1 to that, divided by 2, and it gave me 76. So that's the position of the median. It is not the median. And so I needed to count 76 spots from the start or from the end. And once I counted 76 numbers in, the score was the median. So starting here at the bottom, 14 plus 15 is 29. So I'd count through 29 numbers before I got to an 8. And then 26 numbers onto that would give me a 55. So I could count through these first three classes and I'd be only through 55 numbers. Well, I need another 21, so count another 21 puts me right here. And so the score that corresponds to that is a 7, and that's why the median is a 7. Mode is the number that shows up most often. And so with a group frequency curve, it's easiest. You look for the largest frequency, and the corresponding score is the mode. Mid-range, as we said before, you take the smallest number, which is a 0, add it to the largest number, which is a 10. Notice I'm looking at the scores, not the frequencies, and divide that by 2, and that gives me a mid-range of 5. So that's how we calculate mean, median, mode, and mid-range for a grouped frequency curve. Those are measures of central tendency. Oh, we did that one. Let's look at this one. So back to looking at average. Remember, average is a generic term. The average could be mean, median, mode, or mid-range. All of those are averages. So if somebody says the average, they mean one of these. Odds are good they're talking about the mean. But the mean is just one type of average. We've also got in this calculation this symbol sigma right here. It's a Greek letter. It means sum. So when you see sigma, think sum. So this is the sum of all the data points divided by n, which is the number of numbers, the number of data points. So we did that here with this data set down below. This is the results of a survey. They asked people from these various countries, is inventiveness, or the tendency to be an inventor, something we learn or something we inherit? China had 92% of their respondents say it could be learned. Brazil only had 75% of their respondents say it could be learned. So what we did was we calculated the mean of those who agreed with the idea that it could be learned. And so we took the sum of all the values and divided it by the number of values, and we got a mean of 79.9, which is here at this black line. We found the median. We had 10 numbers, so we needed to count up 5, which is here, and count down 5, which is here. And because we have an even number of numbers, we needed to find the mean of those two. That's why we added 78 and 77 and divided by 2, and that gave us the median. So if you have an even number of numbers, you take the mean of the middle two. If you have an odd number of numbers, you just count in and there will be a single value there. The mode is the one that shows up most often, and that's here. 77 showed up 3 times and no other number did, so that's the mode. Mid-range is the largest value plus the smallest divided by 2. So I know that was rushed, but so I need to apologize because I didn't start recording earlier. But that gives you 12.2 and 12.3. In 12.2, we talk about this measure of central tendency where you've got mean, median, mode, and mid-range. With 12.3, we talked about standard deviation, where we did this calculation. I should also mention that this calculation here with the group frequency was also found in 12.2. 12.3 was where we were introduced to range and where we calculated standard deviation. So take a look at the homework. Feel free to review this video as many times as you need to. If you have questions, reach out to me and I will answer those as best I can. Again, I apologize for the quick introduction. I wish I had hit record earlier, but hopefully this at least will help a bit. Have a good weekend. Bye.